Hello my dear students. So in the previous chapter, we started discussing the reactivity of metals. Under that topic, we discussed the reaction of metals with oxygen in air and also the reactivity of metals with water. Water means cold water, hot water and steam. So from all those observations, you all can remember that metals like sodium, magnesium, they react fast with air and water. Whereas metals like zinc, iron, copper, they show moderate reactivity compared to sodium and magnesium. And metals like silver, gold and platinum, they don't react with either oxygen or water. So that is how the reactivities are. So from that, it is clear to you all that different metals show different tendency of reaction with both water and oxygen. Similarly, they show different tendencies of reacting with acids as well. So in this topic, reactions of metals with dilute acids, we will try to understand how metals react with acids and the products formed and how fast they will react. So to understand that, first we need to know the acids that are frequently used, mainly in the laboratory. So if we take a lab, I'm sure you all have been to the lab, so you would have seen different acids. What are the acids that are commonly used in the laboratory? You all know about hydrochloric acid, HCl. HCl is hydrochloric acid. Then there is H2SO4. H2SO4 is sulfuric acid. Sulfuric acid. And then we have HNO3, that is nitric acid. So hydrochloric acid, HCl, H2SO4 is sulfuric acid, HNO3 is nitric acid. And these are present in the form of solutions. These are all solutions. And these solutions can be either dilute solutions or concentrated solutions. Normally, when these acids are mixed with water, we get the aqueous solution. And there, if the amount of acid is less and there is more water, then the solutions are dilute. If the amount of acid is higher, greater, then those are concentrated acids. So here, we will be discussing the reaction with dilute acids only. So here, it is the dilute acid. So, dilute hydrochloric acid, dilute sulfuric acid and dilute nitric acid. So, let's move on to the next slide where we discuss these reactions. So, to understand the reactions, first we will look at an activity. Activity, study the reactions of metals with dilute hydrochloric acid. So, to do this activity, we need these materials, the required materials. Here we need to have hydrochloric acid, that also it has to be dilute hydrochloric acid. Then we need test tubes. We need test tubes and here we have aluminium. Then we have copper and on this side there is zinc, magnesium and iron. So, different metals. We need dilute hydrochloric acid, we need a few test tubes, Then we need aluminium, copper, zinc, magnesium and iron. So those are the materials that are needed. This is what we will be doing. We will take a few test tubes. We can even label the test tubes with the name of the different metals. And we take equal volumes of dilute hydrochloric acid. And if we take similar sized pieces of all the metals, it would be easier to compare as well. Then we take those pieces of metals, put each metal into the respective test tube containing acid. And we observe the rate of fizzing. Rate of fizzing means when these metals react with acid, they will liberate a gas and it will be hydrogen gas. So we look at the rate of fizzing. That will be the activity. So let us look at the procedure again and then we will do the activity. So the method: add 100 milliliters of dilute hydrochloric acid solution each to a few test tubes. Add pieces of metals magnesium, aluminium, zinc, copper and iron with well-cleaned surfaces. That's very important. Again here you all know students, usually magnesium. When it is in the lab, it reacts with air, atmospheric air, and the oxide layer is formed. So normally you don't see the shine of the magnesium strip. There is a layer over it. So we clean it with a sandpaper. So when you clean it, you can see the shiny surface. That's the metal. So all the metals, even aluminium, zinc, copper and iron, we have to make sure they are clean. So that means there is no oxide layer or any other layer over it. So it's the metal. So well cleaned surfaces separately to the test tubes and you need to observe. Compare the rate of fizzing. So usually when metals react with dilute acids, hydrogen gas is evolved. You can remember this with reaction of water as well. There also I mentioned to you all, when metals react with either cold water, hot water or steam, they evolve or liberate hydrogen gas. The same way, metals with dilute acids, they evolve hydrogen gas. Just to look at an example, if magnesium reacts with hydrochloric acid, magnesium chloride and hydrogen gas are the products. So their hydrogen gas is liberated. So when these metals react, they react at different speed. So that is shown or observed with the rate of fizzing. If the hydrogen gas bubbles are liberated fast, if the rate of fizzing is high, that means the reaction is high. If the rate of fizzing is less or slow, that means the reaction is slow. So that is how we compare the reaction. So here you can see we need to balance the reaction by putting a 2 as the coefficient in front of HCl. So this is going to be a dilute acid solution. So first we will use hydrochloric acid. With hydrochloric acid, we will observe the reaction of all these metals: magnesium, aluminium, zinc, copper and iron. So again students, this is a very simple activity. Let's go to the lab and do the activity now. Okay students, so now we are going to observe the reactions of metals with dilute acids. So to do that, I have 5 different metals here. You all can see. So here I have aluminium, copper, iron, magnesium and zinc. 5 different metals. So here also students, I have labeled the written the standard symbols of those 5 metals, and into the test tubes we need to take acids. You all know there are 3 different acids that are commonly used in the lab: hydrochloric acid, sulfuric acid and nitric acid. But here we are going to do the reaction with hydrochloric acid, and that also dilute hydrochloric acid. So I have a solution of dilute hydrochloric acid here. We need to take 10 milliliters of dilute hydrochloric acid solution into each test tube. So I have already taken 10 milliliters of the acid into the 4 test tubes here. To this test tube, I will add 10 milliliters of HCl, that is hydrochloric acid. So, to measure the acid, we need to use the measuring cylinder. So, here I have taken 10 milliliters of dilute hydrochloric acid. So, I will transfer that into this test tube as well. So, we are supposed to use identical test tubes or at least similar test tubes, and then we need to take equal amount of the same dilute hydrochloric acid solution, that is 10 milliliters. And here you can see, students, almost the metals are of similar size. So, I will be putting each of the metal into the test tube containing acid. So, I am going to put all the metals into the hydrochloric acid solution. First it is the aluminium, then we have copper, then we have zinc, then we have the magnesium strip, and finally iron. So, now you all can see, students, aluminium strip, then zinc, and also magnesium. All these three, they are reacting already, and you can see the evolving or liberation of gases. But in copper and iron, you cannot see the liberation of gases. So, from this side also I can see. And again, students, if you look at the rate at which the reaction is taking place, you all can see all three are somewhat fast, or they are almost very fast reactions compared to the other two. Whereas in copper, there is no reaction, and also iron, still there is no reaction. So, you all have to observe that the hydrogen gas is liberated, and also the rate at which the hydrogen gas is liberated is somewhat different. So, here of course we are not comparing each and every one, we are trying to observe whether they react with the acid or not, or we are just trying to compare whether it's a fast, slow or no reaction. So, as you can see, aluminium, then zinc and magnesium, they are all reacting fast. Whereas in copper, there is no reaction, and iron also there is no reaction. So, here students, you all can see the reaction of magnesium is almost complete. Still there is a small amount of liberation of hydrogen gas, but it's almost like complete. Compared to the previous rate, it has become slower. Now, here also you can see even with zinc, the rate has decreased. The reason is the hydrochloric acid is being used up. Because of that, the reaction has slowed down a bit. But still, aluminium is reacting. But still you can see copper, there is no reaction, and iron also hasn't started reaction yet. Usually the reaction of iron with hydrochloric acid is somewhat slow. So, okay students. So, still iron has not started to react with dilute hydrochloric acid. So, from the observations, you all can see students, aluminium, zinc and magnesium react fast with hydrochloric acid. But iron actually reacts very slowly with hydrochloric acid, but still we have not seen the reaction starting. It takes quite some time. And copper, it does not react with hydrochloric acid. So, that is how the different metals react with hydrochloric acid, that is dilute hydrochloric acid. So, when metals react with dilute hydrochloric acid, normally they form the metal chloride. So, for example, if it is magnesium and HCl, you all know it is MgCl2 magnesium chloride and liberate H2 gas. The same way, zinc forms zinc chloride and liberates hydrogen gas. And aluminium forms aluminium chloride and liberates hydrogen gas. Whereas iron, if it reacts with hydrochloric acid, it's a slow reaction. It forms iron chloride and also liberates hydrogen gas. Whereas copper does not react with hydrochloric acid. So, there are also, you all can see, some metals react fast with hydrochloric acid. Some react slowly with hydrochloric acid and copper does not react with hydrochloric acid. Same goes for some other metals like gold, platinum. They don't react with acids as well. Okay, students. So you were able to observe the rate of fizzing clearly when I did the activity. And you saw that with magnesium, aluminium and zinc, the rate of fizzing was very fast. They liberated hydrogen gas very quickly and the reaction also completed somewhat quickly. Whereas iron, it took some time to start fizzing. So it was a very slow reaction. But copper, you didn't see any change. So there were no changes observed, or that means there was no reaction, no fizzing at all. So that means metals like magnesium, zinc and aluminium, they react fast with acids. Metals like iron, the reaction is slow, and metals like copper, they don't react at all. Like I mentioned before, we did not try the reaction with sodium. Why? Sodium reacted very violently even with water. So if we put that into acid, it will be a very, very violent reaction. So that's why we started from magnesium. Magnesium, the reaction is somewhat fast. It is a fast reaction but not a violent reaction. So those are the observations. Rate of fizzing. You can write it as FISSING or FIZZING. Rate of fizzing with magnesium, zinc and aluminium. Fast. I am not comparing each of the metals separately. We are just comparing whether it was fast, slow or no reaction. Then we had iron. It was slow, and copper, no change was observed. So from these observations, we can come to a conclusion. What can you all conclude? Or what can we conclude from these observations? Metals like magnesium, aluminium and zinc react fast with dilute hydrochloric acid. Then metals like iron reacts slowly with dilute hydrochloric acid. Copper, that is Cu, does not react with dilute hydrochloric acid. So that is how the reaction is. So we observe the reaction, we observe the rate of fizzing. Magnesium, zinc and aluminium, the rate of fizzing was fast. Iron, it occurred slowly, and copper, there was no change observed. And from that, we were able to conclude that metals like magnesium, aluminium, and zinc react fast with dilute hydrochloric acid. Metals like iron react slowly with dilute hydrochloric acid, and copper does not react with dilute hydrochloric acid. So those are the conclusions. And from this, you will have to note, students. Now, as a note, when metals react with dilute hydrochloric acid, the metal chloride and hydrogen gas are produced. So that is something you have to remember. And already I showed you all a reaction with magnesium. Say if you write the reaction with zinc, again it's going to be a similar reaction. Zinc with hydrochloric acid, you will get the product as zinc chloride and hydrogen gas. So this is the chloride of the metal and hydrogen gas are evolved. So for all these, you will need to write the balanced chemical equation. What type of reaction is this? Is this balanced? You need to check. Now zinc, we have zinc chloride and H2. So we need to have 2 hydrogens and 2 chlorines. So we need to put a coefficient 2 in front of HCl. Zn plus 2HCl gives rise to ZnCl2 plus H2. And what type of a reaction is this? Zinc displaces hydrogen. In the earlier reaction, you can remember magnesium displaces hydrogen. So the metal displaces hydrogen. That is why the hydrogen gas is evolved or liberated. So here, of course, this is going to be a single displacement reaction. So you have to relate everything what we discussed before as well. I told you all, when you look at the reactions, you should be able to identify what type of reaction they are, and you should know to balance the equation. So with that, students, I will move on to the next slide. Gas bubbles evolve fast from the test tubes containing magnesium, aluminium and zinc. These are the observations we got. So here, gas bubbles evolve fast from test tubes containing magnesium, aluminium and zinc. Gas bubbles liberate slowly from the test tube containing iron, and no gas bubbles are set free from the test tube containing copper. You were able to observe this. So you are clear with the way the metals react with dilute hydrochloric acid. So then I'll move on to the next slide. Now here there is something you have to remember, students. You have discussed this before also. When we have, I will read this first, HCl is called hydrogen chloride when it exists as a gas. When hydrogen chloride gas is dissolved in water, the solution is called hydrochloric acid. So we have the same chemical formula, HCl. If it is in the gas state, we call it hydrogen chloride. Gas state is hydrogen chloride. Normally, to denote the state, we write it as HCl, only the first letter of the physical state. So, HCl gas, G means HCl gas, that is called hydrogen chloride. The same way, HCl aqueous is termed as AQ, that is the solution. Solution is called hydrochloric acid. HCl solution is called hydrochloric acid. So, gaseous state, we call it hydrogen chloride. Aqueous state or the solution state, we call it hydrochloric acid. But the chemical formulae, it's the same, HCl and here also HCl. Is that okay, students? So, with that, I will move on to the next slide. This shows that the rate of reactions of metals with dilute acids differ according to the type of metal. So far all the reactions that we have been discussing, reaction with air, reaction with water and reaction with acids. So they all differ according to the type of metal. So then it is seen that copper metal does not react with dilute hydrochloric acid. So copper does not react with dilute hydrochloric acid. And many metals react with dilute sulfuric acid, also liberating hydrogen gas. This is also something you need to remember, students. Now we said there are three common acids that are used in the lab. Dilute hydrochloric acid, dilute sulfuric acid and dilute nitric acid. Out of those, we looked at the activities. We did the activity only with dilute hydrochloric acid. The same way, metals react with dilute sulfuric acid as well. So, they liberate hydrogen gas. As an example, if we consider the reaction of magnesium with sulfuric acid, H2SO4, here also you will see magnesium will displace hydrogen. So, then what would be the product? Magnesium sulfate. So, we will get magnesium sulfate and hydrogen gas. Mg plus H2SO4 will give rise to MgSO4 plus H2 gas. So, this is also a single displacement reaction. Single displacement reaction. So, like the previous activity, if you take dilute sulfuric acid into similar test tubes, the same volume, and you put small pieces of each metal, cleaned metal into all these test tubes, you can observe the rate of fissing. That is because all the reactions, there is hydrogen gas evolved. But in hydrochloric acid, you were able to observe that copper does not react with hydrochloric acid. That is dilute hydrochloric acid. So, similarly, there are reactions of metals with dilute sulfuric acid evolving hydrogen gas. But you have to remember, students, these are all dilute acids. Now, we are discussing the reaction with dilute acid only. Dilute hydrochloric acid, dilute sulfuric acid. If the acids were concentrated, especially dilute sulfuric acid, instead of that, if we use concentrated sulfuric acid or concentrated nitric acid, then of course the products can be different. Again, it will depend on the metal, but there can be different products. So, these reactions, what we have written as single displacement and as common reactions, we have considered a few. Those are with dilute acids only. Dilute hydrochloric acid and dilute sulfuric acid. Is that clear to you all? You all have to remember that. With that, I am going to move on to the next slide. However, reactions of metals with concentrated sulfuric acid and nitric acid may give other gaseous products. That is very, very important. You have to remember that. When there is concentrated sulfuric acid and nitric acid, they can give other gaseous products. For example, nitrogen dioxide gas can be evolved with concentrated nitric acid, NO2. You might be familiar with this gas. It is a reddish brown color gas or a brownish color gas, nitrogen dioxide. The same way, sometimes sulfur dioxide, sulfur trioxide, there are different gases that can be evolved. So just remember this, when metals react with concentrated sulfuric acid and nitric acid, they may give other gaseous products. One example is nitrogen dioxide. Then another one. When you look at metals like potassium, sodium and calcium. Now we already did the reaction of sodium with water. That was a violent reaction. Then there itself I told you all we did not try the reaction with hot water or steam, because I told you it might be very, very violent. So here this is with acid. Even with dilute acid, potassium, sodium and calcium, they react violently, even with dilute acid. So because of that, we normally don't try those reactions in the lab. Metals like potassium, sodium and calcium react violently with dilute acids. So that is the reason why we don't normally try this reaction. When I discussed the activity also, I told you all we are not using sodium. It may cause even an ignition with explosion. So it can catch fire and there can be explosion. So therefore, those reactions must not be tried in the laboratory. They should not be tried in the laboratory. You have to keep that in mind. From the above, it is seen that the reactivity of metals with acids varies with the metal. So you should remember with these, from all the observations, the reactivity of the metals with acids, they vary with the metal. So you have to remember that as well. If we summarize all the reactions. Now you can remember, students, we will write down all the reactions that we observed during the activity. So as I told you all, students, you need to know to write the balanced chemical equations for all these reactions. So we saw the reaction of magnesium with hydrochloric acid. What were the products? Magnesium chloride and H2 gas. So to balance, we need to have 2 hydrochloric acid. And this is a fast reaction. This is a fast reaction. The same way, we did the reaction with aluminium. Aluminium and hydrochloric acid, you will get AlCl3 and H2 gas. We have balanced this type of reaction before. Aluminium plus HCl. In order to balance the gases, we put a 2 here, 3 here for hydrogen. So we put a 6 in front of HCl. Can you remember that? So aluminium, 2 aluminium plus 6 HCl reacts to give 2 AlCl3 and 3 H2 gas. That is the balanced chemical equation for the reaction of aluminium with hydrochloric acid. Now this is also a fast reaction. This is also a fast reaction. Then we had the reaction of magnesium, aluminium and zinc. That was also fast. HCl, again zinc chloride and H2 gas are produced. So here, in order to balance, we need to put a 2 in front. So this was also a fast reaction. Then we had iron. If you remember, iron with HCl, it produces FeCl2 and H2 gas. Iron with HCl. So here also we need to put a 2 there. Iron with hydrochloric acid, you can remember Fe2 plus ions, we call it ferrous. So, ferrous chloride or iron chloride is okay. Ferrous chloride with evolving liberating hydrogen gas. Then what happened to this reaction? This was a slow reaction. Then the next one, we had copper with hydrochloric acid and there was no reaction observed. Then, what else did we can think of? Now, earlier also we discussed metals like silver, gold and platinum. They also do not react with dilute acids. So, here in addition to that, we can consider the metals like silver, gold and platinum do not react with dilute acid, that is HCl. So, we have compared all these metals, the reactivity of metals with dilute hydrochloric acid. Magnesium, zinc, aluminium react fast. They produce the chloride of the metal and evolve hydrogen gas. Iron again reacts with HCl and forms the iron chloride and also liberates hydrogen gas. All those are single displacement reactions. But copper does not react. We did not try with silver, gold and platinum, but from previous examples you all can think, you can understand that they do not react with dilute acid. Is that clear to you all? So, with that students, I will move on to the next type of reaction where we look at the reaction between a metal and the solution of another metal, salt solution of another metal. Reactions of metals with solutions of other metallic salts. So, here look at this term metallic salts. When we say metallic salts, now earlier we saw all the metals reacting with hydrochloric acid. There one of the products was either magnesium means magnesium chloride, zinc means zinc chloride, aluminium means aluminium chloride. The same way when I wrote the reaction of magnesium with dilute sulfuric acid, we got magnesium sulfate as a product. Now all these magnesium chloride, aluminium chloride, zinc chloride, ferrous or iron chloride, magnesium sulfate, all these are known as salts. So, metallic salt means those are the substances, and if they are in the solution state, we will try to see how another metal reacts with the solution of the metallic salt. So, similar to those, copper sulfate is also a metallic salt. So, copper sulfate is a salt of the metal copper. Is that clear to you all? So, magnesium sulfate is a salt of metal magnesium. Aluminium chloride is a salt of metal aluminium. So, like that, copper sulfate is a salt of the metal copper. An aqueous solution, here we will be using aqueous solutions, the salt dissolved in water. So, you have seen copper sulfate, it is available in the form of a blue color crystalline solid. It's available in the lab. When you dissolve it in water, it dissolves well and you get a blue color solution. So, that is the aqueous solution of copper sulfate can be prepared by dissolving this salt in water. Let us use the reaction of the metal zinc. So, we are going to use the metal zinc here with the copper sulfate solution in this regard. So, reaction of metals with the solution of other metallic salt. So, here the metal is zinc, the other metallic salt is going to be copper sulfate. You don't take the same metal. You don't try a reaction with zinc and zinc sulfate. There's no point because they are the same metal. So, you need to have one metal and the salt solution of another metal. So, zinc and copper sulfate solution. So, this is the activity. Explore how metals react with the solution of salts of metals. So to do that, we need these materials. First, we need a beaker or a few beakers. Then we need copper sulfate solution. Copper sulfate solution. If we don't have it in the solution form, if you have the copper sulfate solid, you can take a small amount of copper sulfate solid and you can dissolve it in distilled water to get the copper sulfate solution. Then we need the zinc metal. Zinc metal. Similar to this, in addition to this reaction where we try to react zinc with copper sulfate solution, to compare the reactivity of metals, what I will do is, I will also show you all the reaction of copper with zinc sulfate solution. So here the metal is going to be copper and the salt is going to be zinc sulfate. So one reaction we will try copper sulfate solution and zinc metal and the salt solution of another metal. Again we will try copper, that is also a metal, with the salt solution of another metal, that is zinc sulfate. So this is what we will do. We will take a small amount of copper sulfate into a test tube or even a beaker. Into that we will put a small piece of zinc metal. Then you can observe what happens there. Then what I will do is, I will take a small volume or even equal volumes. Let's say if we take 50 centimeter cube there, we can take 50 centimeter cube here. 50 centimeter cube of zinc sulfate into a beaker, and into that I will put a small piece of copper metal. So then you can observe what happens there. Is that clear to you all? So let's go to the next slide and look at the procedure again. Thereafter we will do the activity. The method: add copper sulfate solution to the beaker. So here we will need to have 2 beakers. And the other beaker. So in one, in this copper sulfate solution, as I said, aqueous refers to solution, AQ, because it is the aqueous solution dissolved in water. Into that we will put a piece of zinc metal. Into the other beaker we will take zinc sulfate solution, and into that I will put a piece of copper. So 2 activities, and we will observe what happens there. Add copper sulfate solution to the beaker. Add a zinc granule to it. Record the observations. Add zinc sulfate solution to the beaker. Add a copper granule to it. Record the observations. So we will do these 2 activities. We will compare the results of the 2 activities. So let's go to the lab and do the activity now. Okay students, so far we have been discussing different reactions where we discuss the reactivity of metals. In that, we will now try to understand how metals displace another metal from its salt solution. So to do the activity, I have copper sulfate solution here. So in this the metal is copper sulfate, salt of copper. And into that I will be putting the zinc metal. So we will observe whether zinc can displace copper from copper sulfate solution. At the same time, now this is not given in your activity, but to confirm whether copper can displace zinc from the solution or not, I have the zinc sulfate solution here. You can prepare this by reacting zinc with sulfuric acid. When zinc reacts with sulfuric acid, zinc sulfate and hydrogen gas are produced. So from that I have prepared zinc sulfate solution. So what we will do is, we will take the solutions into a test tube and add the respective metal to it. So first I will take a small amount of copper sulfate. So this is the copper sulfate solution. Into that I will put a piece of zinc. So this is copper sulfate, the metal is zinc. So I'll put a piece of that and we will see whether it reacts. We will have to wait for some time. You all are familiar with this reaction, students. Copper will deposit at the bottom. You can see the zinc dissolving. So zinc actually displaces copper. We have seen this reaction before also. So here, students, you can see it takes a little time for the reaction to occur. Because it takes a little time for the reaction to occur, what we will do is we will keep this aside and then we can observe it in a while. So while I place it here, I will take the zinc sulfate. You all can see it's a clear colorless solution. I'll take a small amount of zinc sulfate into this test tube and into that I will put a piece of copper, a small piece of copper metal. We'll leave that also in a side. Now here you can observe these places. Can you all see the brown color, the solid forming? So there, that is copper. And here also you can see the copper slightly coming and depositing on that surface. So that is where the displacement reaction is taking place. Zinc is displacing copper from the copper sulfate solution. So copper will deposit. So here, students, you all can see the brown color copper depositing. So that means zinc reacts with copper sulfate forming copper and zinc sulfate. You all are familiar with this reaction. If we leave it like this for some time, completely copper will be displaced from the solution and you will see the deposit of copper. So I will leave that aside. And again, if we look at this, can you all see any change here? Is there any change? There is no change at all. So there, copper does not displace zinc from its solution. Copper does not react with zinc sulfate, or in other words, copper does not displace zinc from the solution. So to completely understand this reaction, students, I have already done this reaction and I have a solution where copper has been completely displaced by zinc. I will show that to you all. So here also I already took the two different solutions. Here you can see nothing has happened to copper. It still remains the same. But here you can see from the copper sulfate, copper has been completely displaced. You can see the brown color solid there. That's copper. So here the color is also very, very light. Almost you can say it's colorless. So that is how the reaction occurs. When you put zinc into copper sulfate solution, zinc is displaced. At the same time, when you put copper into zinc sulfate solution, there is no reaction. So from these observations, students, we can get an idea about the reactivity of metals. Zinc is more reactive than copper. That is why it is able to displace copper from copper sulfate solution. But copper is less reactive than zinc. Because of that, it cannot displace zinc sulfate solution. So those are the observations and conclusions that we can get from all these reactions. All the reactions of metals with different substances. Okay, students. So did you all observe the changes that happened during the activity? I am sure you all did. So when I put a piece of zinc into copper sulfate solution, you were able to see that the color of copper sulfate decreases a little bit and also there is a brown color solid depositing at the bottom of the container. So that is copper. So that means there was a reaction. Copper was displaced by zinc from its solution. We took copper sulfate and we put a piece of zinc. So, zinc metal displaced copper from the solution. That is why copper deposits at the bottom of the container. But when we did the second activity, where I took zinc sulfate solution and put a piece of copper into it, there was no reaction observed. There were no changes observed. That means copper did not react with zinc sulfate. In other words, we can say copper did not displace zinc from the metal solution. Is that clear to you? So, from those two observations, we can also confirm copper can be displaced by zinc from the copper sulfate solution, whereas zinc cannot be displaced by copper from zinc sulfate solution. Those are the two conclusions that we can get from the activity. So, if I write down the observation, copper sulfate plus zinc, blue color decreases, blue color of the solution decreased, and we were able to see brown color solid deposits at the bottom of the container. Then we did not see any change. Say zinc sulfate and copper, no changes were observed. So here you saw the change, the blue color of the solution decreasing and also the brown color solid deposits at the bottom of the container, as well as you would have seen the zinc metal dissolving. And I told you all when I did the activity, if we take a larger amount of copper sulfate, a larger volume of copper sulfate, and we let the reaction to complete, then of course if we take the correct proportions, you will see completely the blue color of the solution will be gone. That is, there will be a colorless solution and you will see a large amount of brown color solid deposited at the bottom of the container, as well as the zinc metal completely dissolved. So, if we use the correct amounts of copper sulfate and zinc, you can observe the completion of the reaction. That means completely zinc reacts with copper sulfate, deposits at the bottom, and zinc sulfate solution will be produced. That is a colorless solution. So, that will happen if we do the reaction using correct amounts of copper sulfate and zinc, and if we leave it for a long time. But if you take zinc sulfate and copper, even if you leave it for days, the reaction will not happen. So, from that we can come to these conclusions. Copper is displaced by zinc from the copper sulfate solution. Then we can say zinc is not displaced by copper from the zinc sulfate solution. You have to remember this. Now, there is a reason for this, students. Usually, a metal that is more reactive will displace a metal that is less reactive from its salt solution. So, here zinc displaces copper. So, that means zinc is more reactive than copper. But copper cannot displace zinc. That is what you need to understand from this activity. So, if I go back again, observations, copper sulfate and zinc, the blue color of the solution decreased and the brown color solid deposits at the bottom of the container. With zinc sulfate and copper, there was no change observed. So, from that we can conclude and say copper is displaced by zinc from the copper sulfate solution, but zinc is not displaced by copper from the zinc sulfate solution. And here, you need to understand that more reactive metal displaces the less reactive metal from its salt solution. So, there zinc is more reactive than copper. Or in other words, we can say copper is less reactive than zinc. That is why copper is unable to displace zinc from its solution. You have to remember that, student. Is that clear? So, from all these observations, now we have done 4 sets of activities. We observed or we compared the reactivity of metals with air. Then the reactivity of metals with water. Then the reactivity of metals with acids. And now we try to observe how a metal displaces another metal from its salt solution. So, from all these observations, we will be able to understand the reactivity of different metals. How fast they can react or how slowly they react or whether they don't react at all. So, with that understanding, students, I will move on to the next slide. Here the following single displacement reaction occurs. So, this is again related to the activity that we did, the single displacement reaction. Here also it is a single displacement reaction. Why? Now, when we had copper sulfate, we put zinc into it, we get zinc sulfate and copper being displaced. So, that is a single displacement reaction. But no reaction occurs when copper metal is added to the zinc sulfate solution. The second reaction, there is no change. So, here for zinc sulfate, if you put copper metal, there is no reaction. And from that, we came to the conclusion, reactivity zinc is more reactive than copper. Is that clear to you all? When we consider the reactivity of metals, zinc is more reactive than copper, or copper is less reactive than zinc. So here students, this is the observation and the conclusion that we can get from the activity. With that students, I will move on to the next slide. Only a metal which is more reactive. So this is what I explained to you all. Only a metal that is more reactive can displace another metal from an aqueous solution of it. So like we saw, copper is less reactive, zinc is more reactive. So more reactive metal, zinc, can displace another metal, copper, from its aqueous solution. So copper sulfate solution. Accordingly, zinc is more reactive than copper. So it can displace copper from a copper sulfate solution. But copper cannot displace zinc from a zinc sulfate solution. Thus, of zinc and copper, it can be inferred that zinc is the more reactive metal. So, like I told you, reactivity of zinc is greater than copper. So that is the conclusion of this particular activity. So as I told you all before also students, we have done 4 sets of activities. Reaction of metals with air, reaction of metals with water, reaction of metals with dilute acids, and the displacement reaction. So from all these, we can compare the reactivity of metals, the tendency of metals to react with certain substances, and we can compare the reactivities. So based on all these observations and other properties, these metals have been arranged into a series that is known as the activity series. So with that students, I will end this chapter, and in the next chapter, I will discuss the activity series with you.